Good morning. In the next quarter of an hour, if we rush enough, I will be able to present a brief summary of some of last year's JOSM findings regarding the oil sands air emission inventory and the potential improvements arising from these findings. These two slides define the initial question: what is being emitted from the oil sands, how much, and from where. And the purpose is, these are linked to the purpose, which is to provide the best possible data set for air quality modelers. The activities of the inventory plan within JOSM identify potential sources of air emission information, describing oil sands, facility by facility. Totals are not very useful to modelers. It's good, but it's much better facility for facility, and even in each facility to identify the areas or the emission points and heights, etc. The sources of info included the NPRI, the National Pollution Release Inventory, and the AER databases, which are really not geared to emissions, but provide good support anchorage to the data. Review, assess these information sources, assess uncertainty, or at least some idea of it, and identify potential information needs, and develop a comprehensive and publicly available database on regional oil sands emission, including the three areas. Okay, right. The approach is just to describe, for those who are not very familiar with how emission data is collected in the province. Every year, the oil and gas industry and other sectors report environmental releases to the National Pollution Release Inventory, NPRI, and the data is available to the public in the NPRI website. Just for the sake of simplicity, the NPRI data for 2011 was selected as the reference point for these studies, to which other emission estimates will be compared. NPRI, by its design, does not have information on all pollutants or every pollution source. It collects information that meets the defined reporting requirements and for a given list of substances. To supplement the NPRI data, additional oil sands data was reviewed, including the Alberta Industrial Survey of 2006-2008, several environmental impact assessment reports, which are produced before any new project goes ahead, and special studies carried out for specific time periods of activities. In addition to the NPRI, Environment Canada has another inventory called Air Pollution Emission Inventory, APEI, which augments the NPRI data with estimates for 17 pollutants emitted from non-industrial sources such as motor vehicles, residential heating, agriculture, etc., and is a part of Canada's obligation with some international treaties, among other applications. As the next step, JOSM will look at APEI for further improvements to the modeling inventory. The review of the AER databases was the basis for answering questions like, are significant emissions missing? You cannot interrogate one database alone and determine whether it's something missing. If it is missing, it's there. It's not there, so you're not going to find anything about it. You have to find something that is more comprehensive than that. So all AER activity is licensed, and all production, venting, flaring, and fuel use are accounted for and reported monthly. AER specifies much more explicitly the accuracy of the reported information. I'm going to go over that in later slides. So cross-checking between AER and NPRI databases can help flag information needs. The title appears a little bit odd. There are a number of inventories going around in the province, some for certain areas, and how these areas are defined is something else. There are others that are by activity, etc. To make my life simpler, and I think to meet the requirements of the program, I said, well, I'm going to define the geographical inventory at whatever AER consider oil sands. So this is a geographical domain, and so then software tools were developed to convert the Alberta Township system coordinates and to determine which facilities belong into the oil sands domain. And the map shows the vertices of 17 rectangles that comprise the oil sands area, and that is what is, when I'm talking about the oil sands inventory geographic, this is what I'm talking about. The three areas as defined in this map. Other oil sands inventory were based on activity codes or census subdivisions that may roughly reflect certain area, but not exactly what these 17 rectangles are for. The question of uncertainty is a sticky one, very difficult to define with certainty. This slide that was based on the Alberta Industrial Survey of 2008 shows the for these contaminants, which normally are called criteria area contaminants, how they were quantified in the inventory. And I believe there is no major difference in how were quantified in the industrial survey as an MPRI, because essentially what industry did took the ones that received the summons to present the data probably look at their MPRI site. And you see there in the bar charts the contribution. These sites, by the way, represent only the major sites, the mining, the in situ, extraction, and upgrading. And I'm saying that because we are going to dig later on in the lesser sites. The bar chart shows that the contribution of different quantification techniques to various criteria contaminant extractions. Based on this slide, you see that sulfur dioxide is clearly the best appraised. The transition blue to brown is essentially, the blue is the one that has greater accuracy, and the other one the lesser accuracy. So they are put in by accuracy ranking on the right side. So sulfur dioxide clearly in the inventory is the best appraised contaminants, as indicated with the fact that about 80% of the emissions are quantified by either continuous emission monitoring, SEMS, or material balance. By contrast, in the third bar, you have VOCs, and you see the majority of this is quantified by factors or by engineering judgment. Another way of looking at the issue of uncertainty is the emission mode. How is the contaminant release has a lot to do on how accurate the measurement is. And most criteria, pollutants reported to MPRI are vented through stacks, with the exception of VOCs, which to the most part is released from storage and handling, fugitive sources, spills, and other sources. Stack sources can be my specialty, can be quantified more accurately than non-stack sources due to the internal mixing of the gases and unidirectional movement of the released gases. If you think about, for example, a set of fugitive sources here and there, it's unlikely that you could quantify with the same accuracy that you quantify stack emissions. But all in all, for this list of contaminants, the non-stack emission estimate represent only 13% of the oil sands total. But as you will see in the next slide, are the most uncertain. The uncertainty of the continuous emission monitoring are estimated to be within plus minus 10%, as this is the specified passing mark of the semi-annual accuracy audit required by the Alberta SEMS code. So twice a year, these instruments that are calibrated daily undergo an audit against manual methods, and they have to agree better than within 10% with 95% probability. So it's a very tough code. This is what made possible, for example, in the United States, going to the emission trading, because obviously the burden of proof when you are buying or selling credits is far greater when just reporting the best that you can. Okay, it had to be something more concrete. Most stack tests have similar accuracy, but their extrapolation to annual average adds uncertainty. In other words, you get a very accurate snapshot at that point, but then you're extrapolating this somehow, some cases linked to production for the whole year. Obviously, that adds inaccuracy. Environment Canada commissioned a study on the uncertainty of emission estimate for selected sectors. The study applied a Monte Carlo simulation technique, assuming that information provided to Environment Canada was correct and current, that the input parameters, the activity levels, and emission factors were represented by normal or log normal distributions, and the activity at the sector level was accurate with no uncertainty or bias. The results are summarized in the last 2 points of these slides. Contaminants emitted from stacks can be expected to be plus minus 25 to 45% of the reported value, 19 out of 20 times, whereas contaminants released from non-stack sources had an associated uncertainty of plus minus 80%. This study was not done on the oil sands sector. It was done for cement and the steel sectors, but more or less had the same limitation regarding the area sources being difficult to quantify. You see, this is 15 minutes. I cannot deal with every aspect of the inventory, so I selected 3 issues, or 3, let's call it information need. The first one is mine fleet emission. It's an easy one in a sense that mobile sources don't need to report to MPRI emissions. But there are sources other than facility reporting that provide estimate for the emission mine fleet, and in the case of oil sands, it is important because the fleet NOx emissions are significant contributed to the inventory. And these are the results of this search. Several alternate data sources were evaluated, including, and I will mention them all, the Lower Athabasca Region Source and Emission Inventory compiled by Environs on behalf of CIMA. The 2012 estimates provided, this is the second row, provided by industry to ESRD and processed by the BLIERS, which is the Baseline Industrial Emission Requirement Program of Environment Canada. That's the second row. The various oil sands environmental impact assessment estimate, which were adjusted to the Tier 1. Tier 1 is the type of diesel engines that correspond, that were actually installed. You know, the EIA is done in projection, something that is going to happen maybe 5 years down the road or 3 years down the road. But then you see what fleet was there, and this has to do with the emission from there. And finally, the field measurements carried out by the Desert Research Institute on behalf of WIBIA. Additionally, the APE inventory includes top-down estimate for off-road. When I mean top-down is based on fuel and then goes at estimating the emissions, which could be examined as a next step in the concept of geographical oil sand inventory. The estimate, you see that the years is not the same year. You see 2010, 12, etc. Not a big variation. But in order to compare, I standardize as emission intensity factors. I mean, you take the emissions divided by the associate production of this year. In this case, is the production of the sector that uses the trucks, I mean the mining. And then you end up with a factor in terms of emission divided by the volume of mining. The first 3 estimates are consistent. And the 4th estimate is not too bad, but it's a little bit lower due to sample representative issues, which are discussed in the inventory report, soon to be posted in JOSM portal. The CIMA EAF are preferred as they were based on detailed site-by-site estimate. They may need periodic adjustment as fleet is renewed into cleaner engines. The effect of these estimates on the total inventory will be presented in the last slide. The second information need is emission from conventional heavy oil estimate. In 2011, approximately 14% of the oil sands oil or heavy oil was extracted by conventional means. It came from wells without steam injection. Limited reporting from some facility for certain substances they were maybe due to MPRI requirements, which are focused or designed to capture major sources. By the way, these sources, yes, these sources were not included in some of the inventories that also only focus on the big ones, okay? Many facilities didn't report because they didn't meet the 10-employee threshold and therefore can only be required to report on stationary combustion emissions. And there are some of them that didn't meet the thresholds in which they had to report. Sorry? Oh, to get faster? Yes, sure. All right. Of the 2,500, okay, what I'm showing here is where they are. Essentially, they are not in the study area that was subject of the summer intensive survey, and you see the locations. And some of the facts that lead why we were investigating this. For example, there was essentially very little VOC emission. I said, but we know that it's about 500,000 meter cube of gas is venting from these remote sites. And this is raw gas that contains VOC because it's not just pure methane. The next one is not only the reporting has some suspect numbers, but you also have that the number and the location of the sites differ. Here on the left side, you have operator A that registered 50 MPRI sites. On the other hand, if you go to AER records, that operator appeared only with 5 sites. The effect of these differences is that obviously, if you have many sites, your production, you reduce the threshold of where you need to do reporting. This is a common problem in the US as well. On the right side, the numbers of MPRI sites and the AER site is about the same, but the location is different. So they call into question really, what are we talking about here, these sites, when we see the numbers in MPRI? I try to speed up. Okay, so here is the result on 2011 emissions. The top line is what these sites have reported to MPRI. The middle line is just a sort of a back-of-envelope calculation based on the volume of gas that is vented according to AER records and the average VOC content of this gas that is about 77 grams per meter cube. So you have 16,000 tons. And then at the bottom is a study that was funded by Environment Canada. It was done by Clearstone, completed early last year. And they are not done for the oil sands. They're done for the whole province. But you can carve out the emission intensities and apply to the production of the oil sands. And you see quite different numbers in terms of VOC. Here the problem is VOC that is too low in what is being reported by whatever mechanism. Okay. The next one is the case of the gas emissions. And here is, you can separate in the MPRI the sources which are gas. They report together in the same activity code, but you can separate them by their descriptors. And then you set them aside and see what these numbers look like. There is the location of sites. The oil sand is not an intensive gas production area. Only about 4% of all the gas in Alberta is produced there. Okay? But the reporting, there are 96 oil sands sites reported to MPRI, 90% of them reporting only NOx and CO, and yet there is some problem because there are gas plants, and you know what are the limits of the gas plants, and the limits is much higher than what is being reported. Again, yes, I'm finishing. Yeah. This is the last detailed slide. You have, I want to highlight the SO2 levels and the VOC levels of these three different estimates. So it appears that it's preferable to use emission estimate from conventional gas than the levels that are being reported to MPRI. Okay, what is the effect of all this? And this is the entire inventory for these contaminants in the year 2011. You see, as I mentioned before, the SO2 numbers are good, they're measured all right. Here, the only thing that was missing is that the little SO2 that some of these gas plants were not emitting, 8%. But there are significant increases in the case of NOx, CO, VOC, PM2.5, and H2S from what is in the inventory. And this is what is used. This adjustment will be done in the database for dispersion calculations.